false enthusiast. He works with I2C Lab at University of Houston and Heb Binero Lab at Rice University as part of his PhD. He has previously worked with Mozilla Research Mixed Reality Team and IBM Research Systems Group. He is a GDE expert in web technology and machine learning, Google champions innovator in cloud AI ML, an avid reader, and he loves to watch anime. Please, let's welcome our third speaker, Ravimba.
Thank you,
Now I
Vanya, for
will,
that.
yeah. Now,
Yeah.
now you can share your screen. The stage is all yours.
Thank you, Vanya, for that awesome introduction. Hi, everyone. I'm sure you have a long day till now, and I'm the last speaker now. So I wanted to take a step back and talk towards more fun days about machine learning rather than going too deep about it. We are gonna go a little bit high level on what these quote unquote AI, or rather talk more about the LLMs and some of the more interesting use cases. I wanted to make this talk more interactive, but since this is online, it might be a little bit challenging. So what I want to do is that whenever I might like need some feedback from you, you might, if I ask something, okay, how many of you have done something or something, you can probably just use the raise your hand command here, and that will give me kind of more feedback of from you. So, hi, today I'm going to talk about immersive art and generative AI. What is immersive art and how does it pair up with generative AI? We will delve into that. Uh, so, hi, I'm Rabimbo. That's my friend in the picture, what you can see. Oh, my slides are visible, right?
Yes, you haven't shared your screen yet.
Oh, actually, I did, and good thing I checked. Uh,
Yes, now we are
okay,
seeing your slide.
good thing I checked. So, back to the session. So today we're going to talk about immersive art and generative AI. What does it mean? We'll talk about that a little bit. So first, that's me, and with my friend. That's before I joined my present program. So I'm a Google developer expert in AI ML, also a cloud champions innovator and a cloud research innovator. On my professional side, I'm a PhD candidate. I work mostly in the security privacy, mostly in systems, but right now I also work in AI, or more importantly, like more precisely in LLMs. I work in like LLM safety, you can say. So I'm pretty sure you all don't need this primer, especially after the previous talk, but since I made this slide, I'll still go over that. So what is generative AI? And when I say generative AI, not AI, what is a LLM? What does it do? So, as we can see, LLMs, I want to say kind of like a very, in a very high level, a very souped up prediction machine. It predicts based on what it gets as an input. What are those predictions? So, for example, if you have a sentence like roses are red, what do you think comes next? Anybody has any idea? Maybe you can unmute or just write in the chat.
Violets are blue.
Okay. Anything else? Okay. Why specifically that? Let me go to the next slide. Violets are blue, sugars are sweet. So I'm assuming you probably saw this slide before. But if I am like a normal human, I would say roses are red. Yes, violets are blue, rose sugar is sweet is fine. It might be anything else as well. Roses are red, something else is red, anything. But when LLMs work, they work from a very huge number of data sets from which they kind of try to make these predictions. How? LLMs let us prototype first. When we say prototype first, it's like the creativity aspect of it, or I would say the prediction aspect of it. You can use this for predicting a lot of text or predicting a lot of code, maybe if you want to write a code. Going back to the previous example, what happens here is that the data set this LLM has been trained on, the associations it has made from those specific words or tokens, it has kind of predicted that if something like roses are red is there, there's a high probability, very high probability that the next token might be violet, and the next one after violet might be R, might be blue, and the next token might be a comma, and so on and so forth. That's completely utterly based on the probability distribution on the data set it has been trained on and the architecture. It has nothing to do with that the LLM can reason. Going forward a little bit, this was all nice and fine, and we have all played with ChatGPT a lot and other uh, GPTs. But what about multimodality? So when we say multimodality, this same kind of LLMs or the transformer architecture works with multiple kinds of media. So our input sequence in the previous one was text, but that input sequence can be anything else. For example, by anything, for example, it can be audio, it can be an image, it can be a video. But how? So just here, I was talking about that, okay, these are predictions based on tokens, and it's easy to assume that token as a word. How does it work for audio? How does it work for image or even video? Any of you have played with any of the vision models or models which can produce image but also can understand image? And like what you might have played with? Oh, you can unmute. Okay, Emu model meta. Oh, nice. Anything else? So nobody played with GPT-4? So one of the like most common examples here, I'm assuming a lot of you probably have tried with, is GPT-4. So GPT-4 can create images for you, understand images, even though the creation part is not directly for like GPT-4's capability, but it can understand images for you, everything. If you have played with Gemini, especially the 1.5 model, you would see that it can understand images, it can also understand videos. And then there are models where you can understand audio or try to learn from it. How this works are not all of the models work in a very similar way. Some of them actually convert these models or these different modalities to text before actually doing the prediction. For example, in case of audio, a lot of, or if you have tried with YouTube video, you will find a lot of demos to kind of understand or summarize YouTube video. A lot of them, what they do is that they do it speech to text, convert everything to a textual media, so input sequence is text, and then the GPTs work their magic on that. Uh, for some of the models, some of the vision models, that's not really the case. So they actually try to predict based on images. Not again, when I say vision, I'm saying image. See, I'm not talking about video. Even the vision models which are capable of understanding video, more specifically the open source model called Lava and even GPT-4, how they work is that they don't actually work on the video. They capture specific frames and then try to understand those frames instead of the video. Why this is important? Because video is essentially not just combination of images. As a human, how we see a sequence of images and understand the temporal meaning between those images is not how these LLMs work. So that's something we have to kind of like keep in mind when trying to do anything that deals with real-time audio or video. So this is kind of like a very high-level slide. So welcome to Gemini era, because Gemini now supports audio, video, and all of, and why we might be interested to learn some of its parts. So there are multiple models available inside Gemini and also the open source versions of them. So Gemini has Ultra, Pro, and Nano. So Ultra and Pro, something is we cannot run in our own in devices or instances. The Pro model is famously available in if you go to gemini.google.com and just chat with the model. Mostly you will get access to the Pro model, and the Nano is part of mobile devices, or it's supposed to be part of mobile devices. If any of you is using a Pixel 8 device, specifically Pixel 8 Pro, you already have Nano enabled in your device, and the summarization, text summarization, specifically in the Recorder app and others, they are done by this. This is interesting for us because the Nano model we can actually use by ourselves directly by accessing it, and we will see how we do that. The benefit of it is that your data does not go out anywhere. It's directly processed on device. So there is no chance of like policy violation if that data is very sensitive in nature. If you look at the ecosystem, the Gemini ecosystem, it can be defined into two parts. So one is for consumers where you can just open the app, web app, it's in Gmail, Gmail's assistant, it's in everywhere right now, probably. So you can use that as a consumer. We are more interested in what you can do with Gemini models as a developer. So if you want to build some cool experiments with it, some cool applications with it, how do you kind of start? That's what we are gonna be mostly focusing on. And then if you are like if you are happy with it, if you want to kind of deploy your app in a production or go forward, then there is the other part where you can deploy these models in cloud in Vertex AI, Workspace, or in your own choice of infrastructure. We will also not go there. So we are mostly into the developer part, how you can use the API. Also, some of these, how you can use without using a dedicated API. So what about web? Since when I started the presentation, I said I'm a GD in MLA and AI, but before that, I was a GD for web. Since I used to work with Mozilla, Firefox is very close to my heart, and Chrome is very close to my heart. So anything that runs in web, I'm all into it. So can AI run into web? So when I say web AI is not cloud AI, there is a very subtle difference when I say it's run to web and accessing it through a website. So I'm assuming by now you all have at least experienced ChatGPT or Gemini or Claude or any of these using browsers, right? Using web pages. Just chat with these models. What happens is that your text or whatever you are chatting with goes to a server where the LLMs are running, and then you get the text back, which is awesome. But wouldn't it be more awesome if you could run it directly in your machine without going through anything? Just open up your browser and that's it. You don't have to download anything, you don't have to do anything. And even if you are in a spotty connection or in a place where internet is prohibited temporarily, even then it should work. So let's look at how this whole thing works at presently and if we want to do something different with that. So this is a traditional model, how it works. So you have your AI model running in some cloud, someone's machine, or your own machine maybe. It's running in a dedicated machine, which is not where it's getting consumed. It's running in maybe using your CPU or GPU or a combination of that. And then you have your web application that all your users, your friends, or anybody who is accessing that. And that sends your calls, the API calls to the server, and you get the text back. And that's how it works. Very traditional web app architecture. What about WebXR? So here I'm going to stop again and ask, anybody has any like idea what a WebXR means or have played with WebXR? You can also raise your hand. I'll just get a response. So what is WebXR? So WebXR is called XR, is Web Mixed Reality. I'm pretty sure a lot of you have already heard about Apple's Vision Pro, which came out and which is supposed to be the awesome headset that brings you to immersive reality. Before Vision Pro came out, WebXR or people have been creating immersive applications, and these for at least a decade. So back in 2015, WebEx's first specification was written, and the concept was that if you have a VR or mixed reality application, be that be augmented reality or virtual reality, and you don't need to have a dedicated machine, or you don't even need to have like a software downloaded and that actually runs those applications. So the question was, why can't we expose that in web? Why can't your browsers expose the same APIs, expose some of the capabilities of your VR devices through browser? So essentially, if you run a browser or a Chrome or a Firefox or any kind of browser in your maybe Meta headset, Oculus or HTC Vive or in Vision Pro, doesn't matter where you open that browser. If you have written an application, a web application that utilizes those API, all your user has to do is just open up that web page, and they will be inside a mixed reality application that can take benefits or that can leverage all the device specific APIs. That was what WebEx is supposed to be. Fast forward, right now, WebExer is being used in a lot of different places, and I'm pretty sure a lot of you already use it without knowing it. For example, this is a video of something that right now runs in all of your mobiles. If you have used Google Maps, and you have seen maybe 3 years back, a new feature started coming up where it shows you live location. So if you want to see, if you press on that, it will open up your camera and it will show real time. If it will show like real time marker on real like real scene, that okay, go right, go left, all those. This is what happens inside. So the air code API gives it access to all the depth and visual information. Based on that, WebXR or the WebXR API gives you access that okay, go right, go left. So it brings you spatial awareness. And if you have a, I think, Android device or even Apple device, you probably can already use it in Google Maps. How are these exposed are part of two APIs called AR Core in Android and AR Kit in Apple. So with that, we first want to see that if we want to do it in real life, how you can build some of these. So what we're going to do is that we're going to use WebExer's API to create a virtual reality VR web app that's running in browser. And in the backend, we are going to use some of the information from user interaction to communicate with Gemini to get more immersive experience. So I have recorded it since I cannot show it in a live demo in front of you. So what happens is that, so this is a web application, and I'm gonna share the repository so that you can all run it in your own machine. So it's an art gallery. So we are trying to generate an art gallery. So I'm writing a long prompt inside it, and I'm clicking generate. Once you click the generate, it goes back to the API. It tries to communicate with it, and then it should generate something. Maybe I should make it no, then you cannot hear the rest of the things. So what we're trying to do is that we are using the WebExer APIs to generate. Okay, so it got generated. So we gave it a specific scene. These images are generated by Gemini based on the prompt we just sent. Okay, the recording is really bad. But what happens is that when you run it in your own machine, you will be able to see when you press the info, it describes that image. How is the describe process is being worked is that when you press the describe button, it just goes into the API, sends the image as a base 64 image and asks it, okay, for a description. And this scene is in VR. So if you have a headset, you can actually walk around this museum and kind of like experience this instead of seeing it in 2D. So yes, so this is how we kind of like just as an example how you can interact with it, how you can play with this. I'll share the demo in GitHub so that you all can kind of run it on your own machine. Uh, be mindful, the image generation part is using something called Imagine. Imagine is under, let me share the screen. Yes. So this is what I'm using to generate these images. This is the AI image generator. So as long as you give a prompt, it can generate an image. It can do a lot more other than generating image. One thing to keep in mind that it's not part of like all the capabilities are not part of general availability. Some of them are inside preview. So for example, what I used, you will see most of them are inside general availability. So this demo you can run perfectly fine. But you can also do fine tuning, which is part of insider preview, which is not you will be able to use immediately. So what we used in our example right now is visual captioning. You can also go ahead and implement visual question answering. So what you do look like is for your user, walk around the museum and also ask questions specifically on the image, not just captioning. So if you look at visual captioning, essentially, this is kind of the predictions we get. This is kind of the request you need to send it. So that's how we can, that's how easily we can build something like this. Going back to my original slides. So any questions till now? Because now we're going to switch gear a little bit. Okay, awesome. I can answer any other questions later as well. So this was all fine and good, but like I said, I'm very passionate about web and more passionate about browsers. And as long as this, like, even though this is awesome, I would want to have an like a experience where my users are not, or where my users are not kind of boggled by internet connection. This is awesome, this works fine, but this still needs an internet connection in the back end to kind of communicate with the server. Imagine if I was building an application for like a progressive web app, which you only need to access once, and then after every time you access it, you can kind of like open it through directly the web app and it caches in your device. That will not work pretty well with this kind of experience, because even though it caches the web app, these responses are coming from a server, so you still need internet connection, so that degrades the performance, right? So we want something which is more uh, in line. So to kind of demonstrate, if you want to do something like this on your own, these are, so these two slides I can kind of like show that, okay, if you want to generate image or if you want to kind of manipulate image, how you want to do it, and we are gonna go through that. So if you just open this Colab, so you can either scan this QR code or you can just follow this link. And let me share this tab. Okay, so this is, just give me a second. Yes. Yeah. So this is how, if we want to do something and make it bigger. Yes. This is, if we want to do something similar and want to prototype it, just test beforehand. So I'm using Colab to do it. So let's first start installing the APIs so that we can play with it. Meanwhile, let me, while it's doing that, let me go back and share what we want to cover. So this is the collab link, and so the other, we also will cover another collab, which is manipulation. I'm not sure we'll have time for both of them, but I'll anyway want to kind of, oh, I'll share this link as well. I'd anyway want to kind of show you how it works. So let's go back to our original one, share this tab. Okay. So we don't need to restart our runtime because we're running it in Colab. And then I need to authenticate my environment. And once I'm done with it, continue. Okay, so now I need to define which, because these are billable paid, even though it's very small. So I need to define my project, and then we start generating images. Okay. I first invoke the generation model. The latest one is 006, but somehow I lost access to it just before today. So, okay, let's start with, I'll start with a delicious day. We can do anything else as well. If you want me to run something, you can write it in the chat and I'll run it. But you can also do it on your own. Okay, that's how my stick looks like. Just see what it does. Okay. Yes, this stick still looks nice. Make it a little smaller, and it does come with a wine. Nice. Okay, good enough, I guess. Even though the wine bottle looks not very generic. Okay. Then we define certain functions because we want to do a look with that, and I want to generate like a couple of images of a delicious cocktail. Let's make it bigger. Okay, so the cocktails are generated. And now we go back to describe part. So imagine that example we just saw previously, it was what? So it generated images in a museum. Yes, I am actually pretty getting pretty hungry. So we were generating images for a museum, and then we asked describe an image. If you want to first kind of like prototype it, maybe in Colab, this is what we want to do. So we are generating images, so that works fine. Now let's load our Gemini Pro model, and then we want to generate some text content, not sending the image, just getting the text content. So steps to what are the steps to open a bar, and it's going through the steps. So concept and planning, legal, setting up the bar, operational engagement, etc., etc., etc. And then we want to make it a little bit different. What are the steps to open a bar? And to make it more readable, we are just doing it, displaying it in a markdown because we are going to use it later. So this is a step-by-step guide, and it's more readable right now. Once this is set, we also want to generate a menu for this bar. So we just ask it, provide a menu for a high-end bar, give each menu item a brief description. So this is our menu. Looks fine, but this is just a textual menu. I want to do something more. So we can kind of use them to kind of generate more things in the menu, but we also can give a very detailed context of maybe something in the menu and kind of generate it. For example, here we want to generate a pasta. Fine, good enough. But we want to generate in a very specific way. So style, subject, and background. So we define a template where we say that, okay, so this is my image prompt. So that's the delicious buster, which automatically gets inserted here. Sketch modern apartment building, sketch the style, modern apartment building, etc., etc. How it should be look like a studio and a professional photo, and the background should look like a kitchen on a wooden surface and everything. So this gives us a very detailed prompt. This did not produce the image for us. We just rewrote it so that we can have a detailed prompt on it and then use those prompts to kind of generate the images. So if you see all the four images, not all of them kind of followed exactly what we wanted, but these two kind of did. So wooden background, looks like a Korean bar and everything. So you can use these kind of techniques to create your own visual asset pipeline. So you can standardize this output as a JSON. Now the same things we got as kind of like a JSON. So these are the items with names and description, and okay. Oh, okay. So if you see what we did here is that this part. Okay, so this is another interesting thing. So what we did here is we asked it to generate something as a JSON, and if you look at it, anybody has any idea what went wrong with it? Or like, is it a validated like proper JSON? You will see if I go to a JSON validator, if I paste it, it will not be a valid because this part is not part of that. So anything from here is good enough, but the remaining is not. So this is another example of what can go wrong. If something like this goes wrong, like this, that why you cannot generate JSON properly just by prompting an LLM, and this is applicable for all the LLMs, then you have to do something like this. Let me share this trap. So this is function calling. What function calling is that you essentially write a piece of Python code. This example is not for JSON, but you specify functions. These are the function declarations. And when you call your LLM with something and it goes to function, it specifically uses this Python code to generate an output. So for example, there should be, these are other, I wanted to just an example. Okay, here. Okay, so here, once it goes to the location tool, this location tool actually parses it and gets this output like this. So if we go here to the location tool, get location, you will see it's just defined exactly like how it should be and how it works. For JSON, you have to do something similar to get it validated JSON if the output automatically is not correct. So we go back. So that's how we can work with this. I'm not gonna do a troubleshooting right now. I have, I think, less minute. Go back to here. So that's fine. We generated some images and can work with that. But what about if we want to manipulate those images? In the demo, you didn't see a manipulation part, but if we want to manipulate something, we can do that. And when manipulation, what do I essentially mean is that you have an image, you change that image based on like what you want to do. So if you take this link and run it, okay, so this is the image manipulation. So what it does is that similarly, we just define dependencies, define a project, and then let me see if we have time to write. So what we will try to do here is that we'll try to take an existing image, and based on our prompts, we're trying to edit that image using Imagine. So edit an existing image based on what you want. For example, take my screenshot from this talk and say that, okay, make him wear a hat or change the background. Just writing these, can we manipulate these images? Okay, it ran. Uh, we have to set up image mask. So we have to somehow insert our image. So I'm trying to run acred.io UI. This ran, right? Or this is still running? Hmm? Wait a minute. Okay. Um, yes, and that probably will not work because I don't have that model. Okay, so this is not going to work right now. So, okay, this is the example of what I was just saying, that I lost access to this model. So this uses image in like 006, and the last one we used 5. So this probably will fail. Yes, let me check. Yes. Okay, let me see if I can show you this directly into GCP, because GCP also has support for it. Okay. Do I still have access to it? So this is the same thing we were trying to do. Let me first try that if I can at all work with the model. Yes. Okay. So as you can see, things happen in live demo. Going back to my slide.
There is a question from one of our audience. She's
Yeah.
asking how much does it cost to use Gemini?
Okay. So I can actually show you. Let me show you. No, not show you by stop sharing. Where do I share the screen? Okay, so I did this before. So this is my account where I kind of like show these demos. Let me go to my billing. So yeah, so everything I have shown today till now, and including when I was trying to make these demos and everything, all together costed $2.08 till now. You can actually kind of guess, or not guess, like you can calculate the cost it will require by going to this calculator. Not this page. Okay, so this gives you a better idea. So I was using the APIs I was using. I was using Gemini. So Gemini, if I kind of play with it, this is the cost. Assuming most of our like if your users, like if you're in your use case, you will be sending less than 128,000 context in one prompt. These are going to be kind of the cost. You will see this is pretty reasonable. But I didn't use only this. I also used Imagine. Imagine is this one for generating the images. I used only for the generation. This is kind of the cost you have. So this is the one I was trying to use right now, which I think I lost access again. But yes, so if you use for just for generation, it's point 0.2. If I use it for editing, it's 0.2. There are other things you can do. Visual captioning, which that demo was using, is even less. Visual QA is similar. So these are kind of the cost you are looking at. And for most of the use cases, you will see Gemini has a lot of different models with different pricing. What I have seen is for most use cases, just using Gemini 1.5 Flash is enough for the use case. Is there any other question? Okay, I'll just go ahead. So you can just play with both of the collabs. As you have seen, for the second collab, you will have to ask for your project to be whitelisted so that you can play. It probably will take a week to do that, and then you get access for certain number of time, which I think exhausted. So with that, one of the other questions you might have is that what to use and when. Today, I talked mostly about Gemini, but that's not the only option you have. If you want to run something on your own machine, you can run it in using one of the open source models. For example, Gemma's 2 billion parameter model, 7 billion, or 30 billion parameter model. The other ones available, for example, Meta's Llama is very popular and very capable, very good. Mistral is also there. So based on kind of, I would want to say this is like a decision tree based on what you want to use, where, and you can kind of like decide what model you want to use. But remember when I said I'm also very interested in like the web and what we can do with it and everything. So that brings me back to what we can use this for anything in browser. So I want to kind of like work, or I want to have an experience where I can directly run anything in my browser. That brings me back to this. Where is it? Okay. So this is the Gemini Nano model directly running in browser. This does not use any web or any other applications. So this does not depend on any internet activity to work. This is right now directly in browser. The Gemini Nano small model is in the browser. How do we play with it? So for example, let me make this a bit bigger. Even before going to any kind of web page, I want to show how you can access it directly from your console. So for example, this is my browser console, right? So I can directly communicate with my page or any kind of browser APIs with that. So if you have Gemini Nano in your browser, you will be able to use this directly from natively from your web app or even an extension. So the only thing you want to do is first you have to see that if it supports it. So Windows AI. Okay, so it gives me these capabilities. If I go inside AI, this is still in prototype stage. So this creates these sessions. I can create a text session. Is there a question? Okay, so I can create a text session. I can create like text session options and all these. These are all available inside the browser. And let's first start that what we can do with it. So I define a model, create a text session with that, and then I can pass anything I want to that model as a prompt. So can you write a poem for GDG Edmonton? If I run it and wait. Okay, so this is running directly from my browser. Nothing is going out anywhere. This is nice, but how we can use it in our own application? So for example, let me make this bigger.
Hey,
This
John
is,
from, sorry, John from
yeah.
Alberta, Canada. Would you mind to disable your mic unless you have a question for our presenter, Ravimba, please? Thank you.
Okay, so in this web app, this essentially uses this Gemini Nano model directly to kind of question and answer. So how do we make sure that I'm not playing or I'm not sending anything to outside? So let's look at our network tab. So if anything happens, we should see it in network. So no, enough with poem. And let me try. Okay, that should not be the case. Let me make it small. Okay, that came out pretty fast. So what happened with the previous one? So this is running directly in browser without any internet connection. As you can see, nothing is going out. Then let's try this again. Why did it not work? Oh no, Haiku is not code, but yes. Why will it not work? Oh, does it not understand Haiku? Is it giving me the same code again and again? Oh, it is. Okay, that's interesting. Just give me a second. Let me restart it. Let me first go to console and see if that is okay. Unknown error, generic failures occurred. Okay. Oh, so the model is working. My web app is not working. Okay. Let me try to rewrite a code. Okay, it did give me something. So this is, okay, let me see if it changes. Okay, so it is not giving me the same response. So this is working. I am a bad coder, so my code doesn't work, but Gemini works fine. Okay, with that, let me go back. Yes. So if you want to build something on your own, you can use Gemini AI Nano, like Gemini Nano directly in your browser. This is not part of public release yet, but if you want to play with it, you can download Chrome Canary, which already has it enabled, and that's why I had to like switch to that browser to actually use it. Chrome Stable doesn't have it. Chrome Canary has it enabled under flag. If you have those flags enabled, you can actually play with it. So that's all good and fine, but once you start working with that, you also need to have a way to evaluate these services. That it doesn't produce hallucinations, or just how we saw in our own application, it doesn't produce the exact same things. These are different kind of matrices you can use. Auto SSX, SXS is already part of Vertex AI, which you can build or use to kind of evaluate the responses you are getting from the LLM. You can use this to do A/B testing on your LLM, which is if you want to use LLM for any kind of production thing, apart from just playing with it, testing is of paramount importance. In very short, how you work with it is that you submit some set of input prompts comparing two different models, maybe Gemini and Llama, or GPT, for maybe like Gemma and Mistral, something like that, or Gemma, Mistral, and Llama, and you run it, and you have your auto rater to rate them, and you see that for your specific use case, for specifically those prompts, which are good or bad. And also, have you ever received non-answers based on outdated information? For example, ask something and it goes back to says you, okay, this is this. I cannot give you a proper answer, or my knowledge is limited to that. Have you ever tried to kind of give it or ask it an information which is part of a link maybe, but it cannot access those? And have you ever tried to get like consistent outputs? For example, what I just saw in my own demo, the JSON output was not exactly JSON output. So to mitigate most of these, you can use something called, so you are a user, you have generated a model that can use things like agents. These agents are not essentially something anything else. These are like small Python snippets, Python codes, like function calling, which does very specific tasks, which does either validation for you, either getting new data from websites. So a function might be, or a tool might be just a Python function, which is your curl or URL lib to get information from a website, or something which grounds your data. So if you want to utilize a pipeline like that, you can use Model Garden to use that. So you can have function calling to extend the context of your LLM. You can use function calling for testing, evaluation, and kind of grounding your data. You can define what you want, define your own tools using function calling. How we saw, you can use them to make it more performant. So it's mostly about developer control and flexibility. Very simple tasks are already we can do using just prompting. But if you want complex workflow, if you want a workflow that is deterministic, then you might want to look at this function calling. In a very high level, when I say function call, this is nothing fancy. This is what a day in the life of function call looks like. You have a prompt, you send it to Gemini. Gemini goes into these tools, which are essentially just small Python snippets or codes, sees that whichever is relevant, or if it at all anything is relevant, uses them. For example, if you ask it about a person by just sending a URL, it uses that code to call that REST API, get the output of that, and gets back. You can also use it for databases. if you have a RAG pipeline for document repository or any kind of other use cases. Most of the things I talked today are available as a resource in ai.google.dev. So I would kind of encourage you to go there. You can also join the Discord, which has a lot of people who can answer your questions if you have them. Some of the things I showed today are available in these links as a documentation. So Google's Vertex AI and Cloud Platform GitHub repo has a lot of examples, a lot of notebooks you can just try and run. Some of the kind of cobbled up examples I showed today is part of my GitHub repo in GDML artifact. The two you saw today, you can access through those links. Thank you. If you have any question, I'm happy to take that. Otherwise, I am also happy to connect with you in any social platform or if you have any questions. Thank you.
Thank you, Ravimba. That was a great talk and a very interesting demo to see how did you generate images and do some image manipulation with the models. To all people who are now, I invite you to upload